All right. So for the final case study, let's look at another class from the collection library. So in the previous video, we look at the Arraylist class, where there was a generic parameter called E, and E may be instantiated by any concrete class, either from your developments, like a person, or maybe points, or maybe from some class from the Java library, like a string. And this second class that we're going to draw from the collection library actually contains two generic parameters, meaning that in this particular collection, there are two kinds of elements that are actually stored inside the collection, which we have to clarify for you. Okay. Let's now go over some brief definition, and then I'll point to you some resources for your self-exploration and also self-study, and then we'll go on to do one example in detail together with you. Hopefully that will help. All right, first of all, let's go on to the link for the Java API page. But before I do that, let's see what a hash table is. A hash table acts like a two-column table. You can think about it as like a two-dimensional array. The way we visualize it is like a table with rows and columns. Two-column table with searchable keys. I'll talk about what searchable really means. Searchable simply means you can use the keys to actually search a particular entry, like a row in the table. So we'll talk about it later. So a table of keys and also values. So the terminology for hash table will be, you talk about the keys which are used to search for the corresponding values. So key and value. So these are the terminology you want to get used to. All right, so the first link I would like to point to you will be the Hashtable API page. Let's take a look. If you click on the link, let me show to you the web page over here. Right, as usual, I'm just going to give you a very quick walkthrough of the page, and then for the detailed exploration, you should really do it by yourself, not just for this course, but beyond this course, you might find the use of hash table and also another class called Hashmap. They are rather similar, so you can definitely use these two almost interchangeably for the simple application. Okay, so we got hash table here. You can see we got two generic parameters. If you recall how the class for array list was declared, was an array list and only got E. So the names of the generic parameter is really up to the definition for the contributing developer. So in the case of hash table, we got two generic parameters. I will show you exactly how you can instantiate them when I go back to the iPad a little bit later. So we got two generic parameter. The first one is K. So whatever K you actually instantiate it into is going to be the type of the keys inside the hash table. So the key, as long as it's searchable, it can be integer, it can be string, it can be person, it can be whatever, right? And we'll talk about something very specific of using hash table called hash code. And that's something that, again, beyond the scope for this course. And when you get to 2030, the advanced OOP course, you will learn about how you can redefine the hash code in the Java classes. However, for this course, we'll only show to you how you can use it for the existing classes like a string that can be used as keys right away. All right, and then the second generic parameter is called V here, standing for values. And the value, there's no constraint. It does not have to be searchable as long as you actually got it's referring to some existing class like a string, person, point, integer, double, etc. So that'll be okay. So only the K over here should be so-called hashable, but you only learn about hashable in the second year. All right, it's from the Java utility package, so you want to make sure you put the corresponding import statements to use the hash table and then KV, right? The two generic parameters. All right, you can see so you can see some general description over here. You can take a look. There might be some technical details, for example, like a load factor. So that's kind of the theory you'll learn in the second year. May not be even 2030, maybe in 2011 when you learn about the data structure. So you learn about load factor. But for now, you don't need to worry. Just skim through the class to get some basic understanding. All right, they show you some example usages over here. So I will use another example. So you can definitely look at this one as well and try them out in the Eclipse. That's highly recommended. All right, let's now take a look at the summary. Let's say for constructor, we might still use this default one, which will just initialize an empty hash table, like an empty table, basically, right? With no rows. And then you can look at other overloaded version of the constructor yourself and to see if you want to explore further. But we're only going to show you this one here, basic one. We always start the collection with being empty, okay, to begin with. And for the method summary, you can see again we have no static methods, so everything here is simply non-static, right? Number one. Number two, you will see some method over here. You can see either void or not void, right? You can see either you refer to v or you can refer to, let's see if there's anything about k. Actually, you see the parameter. For example, you can see for this particular method, you can see k over here is the type, right? So we're going to do the similar instantiation and substitution like how we did it for array list. I'll show it to you once we get back to the paper. Okay, so at least you should really tell when I look at this particular method here, I know that it's a mutator because it returns void. On the other hand, if I look at, let me give you, let's say here, you got contains over here. Contains is actually a method that returns a boolean, so it is an accessor, public accessor more precisely. And then you can look at this brief summary over here. If you want to learn more about this particular method, you can click on that, and then the API page will show to you much more information over here. Okay, again, I'll let you explore that, and we'll go over just some methods that are more commonly used, and then we'll go over them using one example. Okay, let me move back to the slides, and then there's another link I want to show to you. So there is also another video I created earlier about how you can use another class called Hashmap. However, Hashmap and Hashtable is kind of very similar. It's only they're only different in the way they handle threading. Like a concurrency, but that's not something you have to be concerned about. So you can use either Hashtable or Hashmap in a very similar way. So if you click on this link over here, you will see there is a video here for Hashmap. Okay, and then if you click on the notes over here, I want to show to you one thing, which is not really covered in the slides, right? So if you go to this page over here, it talks about two different ways for you to actually go over the entries in the table row by row, like an entry by entry. So there are two ways to do it. One way is by calling the method for the hash table called keySet over here. Another way is by using the for each loop, but you have to use another extra class called entry. Okay, you can explore this further by going over the tutorial video yourself, right? It's self-study, all right? And it's highly recommended you actually do that. All right, let me go back to the slides, and let me just go over, like before, we want to go over these methods quickly. I only gave you a selection of methods. It's not really exhaustive, right? It's just not feasible for the limited time we got, but that should be enough for you to explore further yourself. All right, let's look at this method here. First of all, you can see that we got the declaration for the hash table is simply with k and v, right? And let's now, to begin with, let's identify that these two variables are simply generic parameters. In the previous case for array list, we actually got just a single generic parameter, just a string. And now in this particular case, we actually got k and v. And k is for the type of keys. Also, the pink one over here, the type of keys. On the other hand, the v over here, it is the type of values. Okay, let's take a look at one example of how you declare a hash table. So let's see this. So let's say here, if we try to declare some variable here, let's say hash table, and then we have to instantiate both k and also v. Let's say, for example, we can say the key is going to be string, and then let's say we're gonna have a hash table mapping from string keys into person objects. So maybe the value can just be person, assuming that person is actually some existing class we define, right? You can see what I meant before when I said instantiating the generic parameter by some concrete class. The class can either be some class from the Java API library, like a string, or it can be some class you define yourself, like a person. Okay, and then we can say table, I will say T over here, is simply assigned to a new objects over here, and then we just repeat that declaration, hash table. And you can look at the tutorial videos. It would be okay for you to simply put this notation over here. So this simply means whatever is inside implicitly will just match whatever you declare over here, right? So that's some convenience Java compiler will allow you to do. All right, and then it's going to be empty, right? It's an empty parameter version of the constructor. So now let's take a look. In the case of the key, you can see it should be k. It's now instantiated by just a string for this particular variable t, right? So now that means every occurrence for this particular API should be adapted to k being string, right? So now you can see that over here. You can see the k. Let me look at every occurrence of k. So you can see the k over here should be a string. And I think that might be the only one. Okay, just the only one in my examples. So what about v? If you look at the v over here, the v is instantiated by person. So now that means every occurrence of v will be replaced by just person for this particular table t. Let's now do that. So you can see here, v here, v here, v here, and also the v here, right? All of them will be replaced by just person. For example, let's say this. If I'm trying to call this particular method over here, let's say the get, right? Let me just highlight it, the whole line over here. So the way to understand this would be, so if I want to retrieve some item from the table, so if I call get, and then, so I'm going to pass any objects over here, which might be the key, and then it's going to return some person, right? Rather than v, because for this particular table t, it's going to return person. Let me write it down explicitly. If I say t dot get, and then I pass some value over here, and then it's simply just going to return a person, the reference to a person, more precisely. All right. And before I go over the method one by one, let me talk about the conceptual model for a hash table. Okay, and then it will be much easier for you to follow the method one by one. So this will be a quick summary about what a hash table is and also what a hash map is. Both are really the same idea at the conceptual level. Number one, it is a two-column table over here. You can see this is one example table. You got a column here for the keys. You got a column over here, the second column for the values. Let's say for this particular column, we are trying to have like a grading table. Let's say here for grading or grades. And then we say that the keys will just be the names of the student. We got Alan, Mark, and Tom, right? So column of the keys contain no duplicates over here. You can see Alan, Mark, and Tom. Remember we said the keys should be searchable, meaning that whenever you're trying to use a name to really search through the table, the name, if existing, must uniquely identify a particular row over there for us to get the corresponding grade for the students, right? So for example, if you somehow you got Alan over here, also if we allowed for duplicates, let's say maybe here this is D. And now in that case, if you want to search by the name Alan, then we got ambiguity. We wouldn't know whether we should really retrieve A or D. So it's really important to see this particular point here. No duplicates is really important, right? So you can see for this particular column over here, no duplicates. And then you might be wondering, when we try to add a new row into the table, what if the key for the new row actually already exists in the table? Are we going to get some runtime error, or the Java API is going to do something different? That's something I will emphasize when we go over the example. Okay. And then the next one, the second column will be for the values, right? You can see the column values may contain duplicates. So here, I don't really have any duplicates over here, but I think about realistically, it would be okay for Alan and Tom both receiving A. So that'll be okay. It's not really violating any rules for the table. And each key uniquely identifies an entry KV. So here we talk about the entry. So the idea about entry is really important, okay? So whenever we talk about hash table, you can think about each row over here, each row. You can think about this is one row. So this is called an entry. And the entry actually contains both the key and also its corresponding value, right? So that's how you understand. So sometimes I might say row, but maybe more rarely, but mostly I'll just say entry. So one entry in the table simply contains two information. One will be the key, the other one will be its associated value. And the keys must be containing no duplicates. Okay. having that conceptual understanding, let's now go over quickly the methods I chose one by one, and then we'll go over one example in detail. Okay, we got size over here that's very similar to the array list example. So size, according to the explanation here, returns the number of keys in this hash table, right? The number of keys, right? You can 1, 2, and 3, but it's also the same as the number of entries, 1, 2, and 3, right? So that's about the size. So now, does the table contain a particular key over here? So for example, does it contain Alan? It does. Does it contain Jim? It does not, right? And also contains the value. So checking the second column. Does it contain A? It does. Does it contain A plus? No, you only got A, B plus, and C, right? Very straightforward. And also for the get. So the get over here is also very straightforward. Given a particular key, if the key actually exists, we're going to return the corresponding value. For example, if you want to say get, if I want to get Alan, I should return A. If I say get Tom, I should return C. What about I say get Jeremy? Jeremy doesn't really exist, does he? In that case, well, when you are not too sure, you should really refer to the documentation like how I did it in the previous video. So let me highlight it, what you should really pay attention to. Or now, if this map contains no mapping for the key, right? So now in this case, if I want to say get Jeremy, but Jeremy does not really exist as a key in the first column, in that case I'll return null, because Jeremy's corresponding value will just be null. All right, and then also put will be for you to reinsert a new row or new entry into the table. Okay, so now you will be basically a string and also person, right? You can see K here. The K over here has been instantiated by the string. And also the V here has been instantiated by the person. Meaning that if I want to add, so I'll show it to you. So it would be something like a T dot put over here. And then the first value over here must be a string. For example, let's say key number 1, for example. And then the second one here should be corresponding to the person, right? You can see person over here. So I can say, for example, let me use some anonymous objects. I can say new person over here, maybe some name over here. I'll leave that omitting the detail here, right? So this can be one possible way to call the method. One thing to know very quickly, according to the header of this particular method, you can see it does return the V type. In this case, it does return the person. However, it's kind of violating the OOP principle that we spoke about earlier. I said that before. If you're trying to use if you're trying to declare an accessor, you should not really try to modify any internal attributes of the objects. However, the developer for the Java hash table, they decided to violate this particular principle. Nothing we can do. It is what it is. So I would say when you're trying to define your own classes, you should always have a clear distinction between accessors versus mutator. However, in this case, if you want to call the put, I might just use it as if it was a mutator, which means I'm not going to use the return value. If you really want to use it, you can feel free to do so, right? It's just something we got to deal with. Okay, finally, this one will be if you want to remove some particular entry, right? Let's say this. If I want to remove, let's say this particular entry, all I need to pass will be just the corresponding key, because a key can actually uniquely identify the entire row. Okay, so that's something I want to mention as well. So here you can think about the key over here can be used to uniquely identify an entry. Uniquely identify an entry. Okay. All right, so that's about the very quick introduction to the hash table. So both the conceptual model you should really have about a 2-column table and also some example methods, and about the 2 generic parameter K and V, which might be instantiated by different classes, either string, person, just one example. All right.